Okay, so this is a guided practice lesson. So here, we're going to build the rigor a little bit, so we're pushing towards a little bit more challenging problems. They all, however, deal with the same skills that you've seen in the last couple lessons. So Pythagorean theorem, triangle sum, and sine cosine tangent. Okay. So as you work through these, you should see that I've tagged each one with a corresponding lesson. So feel free to go back and reference. And also feel free to not watch this entire video. So I've put links and timestamps in the description to each question. So feel free to skip around to just the questions you need. That all being said, this first question is not super challenging. So it says, what's the value of sine x? So this is just a SOHCAHTOA problem. Sine x is going to be opposite over hypotenuse. And the only kind of interesting thing about this is we have an isosceles triangle. That means x is on either side. So in other words, these two angles are the same, and these two sides are the same. So we would expect this side to be 20 as well. That's what isosceles means. But the process for finding sine is the same. Okay, so opposite over hypotenuse, and opposite is the far side, right? So 20 over 24 is my sine. And then we'll simplify. So I divided top and bottom by the common denominator of 4. For bonus points, I'm just noticing this now. I got this problem from a book. This is not actually possibly a right triangle. So if you think real hard about the topics from this lesson, you might figure out why. If you have an idea about it, let me know, and I can tell you right around. Okay, so 5 over 6 is the answer I was looking for there. Next one is where they start to get a little bit more challenging. So here, we have a right triangle ABC above, and we have this x degrees, and we know that cosine of x is 3/5. So cosine of x degrees is 3 over 5. And then it says if BC is 12, what's the length of AC? So we'll call AC, I guess I'll call it y because we already have an x. So we need to find y. Okay, so a couple different ways we could approach this, right? One way we could approach it is we could find x, and then we could make an equation with 12y and whatever x is to find y. So let's give that a try. So we know cosine of x is 3/5 degrees. That means x is going to be cosine inverse of 3/5 degrees. Or 3/5 rather, I should say. Okay, so I type that into my calculator. And that gets me 53.1 degrees for x. Okay. Then I can sort of plug that in. So my second equation, right, we have the opposite side from x and the adjacent side from x, right? So I could say tangent of x is equal to 12 over y. And then I could plug this in. So this is my x, so I could take 53.1, plug it in there. So I could find that tangent using a calculator. And that should get you 4/3 equals 12 over y. And notice now we just have sort of a proportion situation. So one way I could tackle this is by cross multiplying, which you guys know and love. So I could say 36 equals 4y. And that means y equals 9. Okay. So that's one way to tackle this. There is another way to tackle this. And that way would be through similar triangles. So sort of the idea is we've been kind of teasing at the beginning of the unit, right? So let's say I drew a smaller triangle, smaller version of ABC. So this is the cooler way to do this, actually, I think. If cosine of x is 3 over 5, well, that means adjacent hypotenuse, right? Now, I can do Pythagorean theorem, so I can say 5 squared plus or sorry, 5 squared, the hypotenuse goes by itself, right? 5 squared equals 3 squared plus b squared, we'll say. When I solve this, this is a Pythagorean triple, it's called. So 3, 4, 5 are solutions to the Pythagorean theorem. So I'm skipping some steps here. 16 equals b squared, but you guys know how to do these steps, and then b equals 4. Okay. Notice, if I know that this bigger version is 12, well, 3 times 4 is 12, 3 times 3 is 9. So there's a couple different ways to tackle that one, and that's what's kind of cool about trigonometry, is there's a lot of different ways to think through it, as long as you keep in mind the properties of these triangles. Okay, so this is I'd say the cool way, but this way works as well. Okay, moving along. This one I think is the toughest one, right? So it gives you a right triangle, and then it doesn't even give you, the last one we had enough information to figure out our x right off the bat. It doesn't even give you that. It says sine of 90 degrees minus x equals 12 over 13. Right? And you're like, well, that doesn't even help me that much, right? Because I don't know what x is, so I can't figure out this value of sine here. So you really have to think about this one. I gave you a hint and I told you that this is a triangle sum problem, and maybe that helped you. Okay. So if this angle is 90 degrees, that means my remaining two angles, we'll call this one y, that means x plus y must equal 90 degrees. And maybe you see where I'm going now. That means y is 90 minus x degrees. Okay. So really, this sine of x gives us some information about the triangle here. So 90 minus x would be y. This is really sine of y is 12 over 13 in my language here. Okay. Now's a good time to pause on this one and just reflect on whether you're understanding me or not. So what I have done, right, is I've taken the fact that this triangle must add up to 180 degrees and the fact that this right angle is 90 degrees to figure out the relationship between the other two angles. These angles, these are called complementary angles. Maybe you've heard that term before. Complementary angles. Okay. And now I'm going to use what information I'm given to figure out my remaining sides of my triangle. So it's opposite over hypotenuse of y, so that means the bottom of my triangle is 12 and the hypotenuse is 13, right? We need the opposite side from x, right? So sine of x is going to be, I don't know, I'll call it z. It helps to give things names here. Sine of x is going to be z over 13, right? Because that's opposite from x now over the hypotenuse. Okay, now I can just do Pythagorean theorem. So I can just say, I don't know, I'll say z squared plus 12 squared equals 13 squared, right? And this is again a Pythagorean triple, meaning we get three nice whole numbers that satisfy this. And if you stick with math long enough, I don't know, maybe only if you become a geometry teacher, you'll memorize a lot of these. So this gets up being z squared equals 25 and z equals 5. Okay, so z equals 5, and we're almost done. Okay, so now we want the sine of x. Well, we wrote it down already. Sine of x is going to be 5 over 13. Again, I think this is the most challenging one on here. So make sure you understand this one. There's one just like this in the quiz. So make sure you come back to reference this video if you're stuck on that one. Alright, moving on. These are classic. So it says a ladder 500 centimeters long leans against a building, and the angle between the ground and the ladder is 57 degrees. So let's draw a picture. Okay, so we have So this would be like, the building up here. And then this would be the ladder. I'm not going to try to draw the ladder in 3D on my computer here. The ladder is 500 centimeters long, so the ladder is the hypotenuse. And then it says the angle between the ladder and the ground, well, obviously the horizontal is the ground. So this angle is 57 degrees. Okay. How far from the wall is the bottom of the ladder? Well, let's call that x, right? So you can imagine like a ladder. Make sure you can picture this in your head. Like, you guys have all seen ladders leaning against buildings at some point in your life. You want to not walk underneath them because it's bad luck, right? That's what we're picturing, right? So this would be like inside the triangle is the bad luck zone where you don't want to walk. So we need to find this x. We know 500 and we know 57 degrees. This is a SOHCAHTOA problem, right? And what we have based on 57 is adjacent and hypotenuse. So we'd say cosine of 57 degrees equals x over 500. Make sure you have the x on top because x is the adjacent side in this case. Okay? And then what I like to do is sort of leave the cosine alone. This is a number, right? I'm going to multiply both sides by 500 first to get x by itself. Okay. And then I'll do, on my calculator, I'm typing in 500, typing in this whole left side, 500 times cosine x. Or sorry, cosine 57. And I get 272.32. Okay. And then I should label this because it is a real life quantity. This is in centimeters because it was 500 centimeters. Okay. So that's just a set up an equation SOHCAHTOA problem. Last one is similar. These, by the way, are both like simplified calculus problems. So what we might do in calculus next year is set up the same problem, but then I might say my ladder starts to fall down this wall, right? And instead of asking how far is the bottom of the ladder from the wall, I could ask how fast is the bottom of the ladder moving away from the wall. So that's kind of how we're going to level up next year in calculus, make the question a little bit more interesting. Okay. Here, same thing as before, just a little bit more abstract. So all we're looking for is an equation relating these three things. So two ships are a certain distance from the lighthouse rock as shown in the diagram above. So the y distance, x distance, right? Ship A wants to know the angle it must travel to rendezvous with ship B. So you can imagine you're driving ship A, I guess, and you want to go towards ship B. So to do that, you would need to know what this angle is, right? Well, one way you can do that is via trig. And we want an equation relating theta and x and y. What do we have here? We have opposite and adjacent. Opposite over adjacent is tangent, right? SOHCAHTOA. So tangent theta equals opposite over adjacent, which is y over x. And that's it. So no solving there. And this is the solution I was looking for. I was looking for just an equation. And again, next year in calculus, you'll see this problem, this exact problem again, actually. This is from an FRQ. And we'll look at how theta changes, how the angle changes as these ships move around, which is a pretty interesting way to complicate things. Okay, as always, reach out if you have any questions about any of these problems before you tackle the quiz.